So my name is Aleksander Korzyński, and this is a talk about GitKraft. It's actually the first time presenting this. GitKraft is a platform for distributing software as source code. It's something I've been working on for the last few weeks, and it's particularly useful for Helm charts. And I'll show you why. So let me go to the next one. A little bit more about me, Aleksander Korzyński. I'm a DevOps consultant, have over 10 years of experience in DevOps. Some career highlights. I've been a contractor to the University of Cambridge, doing some engineering on the on-premise infrastructure. I've also been a contractor to Priceline.com through TopTal and Google, where I was working on the public cloud infrastructure. And I've had a lot of experience with Helm and Git and Kubernetes. So just one more thing. Today, I'm representing myself, not any of the above, just to make it clear. So what I'm going to talk about. First, I'm going to talk about the problem that GitKraft solves. And then I'm going to talk about the solution. Then I'm going to do a demo. And it's going to be an actual live demo. And then I'm going to talk a little bit more about how it works. And we're going to do a Q&A. So let's go. What's the problem? The first problem is for creators of source code, companies usually, that want to distribute software as source code. I think this is a surprisingly unsolved problem. There are a lot of ways to distribute source code, but what if the user wants to maintain patches on top of the source code? And an example of this is a Helm chart. So a company develops some software that's supposed to run in Kubernetes, and they also provide a Helm chart for it. But the user is some kind of big company that has their own bespoke infrastructure, and they need to modify the Helm chart. Perhaps modifying the values YAML file is not enough. They have to actually go to the source code, the template, make a change to it, make a random patch. How do they do it? How do they maintain a patch in the presence of potential updates? Because in the future, a new version of the software will come up, and they want to update the software, the underlying software, but still maintain the patch. So a couple of ways of doing this. So possible solutions. A tarball sent by email. This is actually being used. I've seen that being used by companies that produce a Helm chart that isn't open source. They just send a tarball by email. And that's a simple thing to do, but it kind of leaves a lot of work on the users, because they need to somehow consume the tarball. It's difficult to automate it if it's an email conversation. And they need to maybe uncompress it and store it in a Git repo somewhere, or a different repo, whatever they do. So some work done by the user. Now, the second option, storing the tarball in a Helm repository or an OCI repository, whatever you want, where you want to store it. That's a bit better, because you can automate that better, but still there are problems. Like, how do you see exactly what changed between different versions? How do you maintain these patches? Still, it's kind of substandard. It's not really ideal. So a Git repo is another option. So the developer, the company that produces the software, creates a Git repo, maybe on GitHub, and it could be public if the software is supposed to be public, or it could be private, and they could invite some user to that organization so that they can access it. That's fine. But again, how do you manage patches? So for patch management, there are a couple of limitations. So one, GitHub does provide a way for you to manage patches, but only on public repositories. So there's a public fork feature on GitHub. I'm sure you've heard about it, you've used it, but it only works with public repos. It doesn't work with private repos. So what if the software isn't supposed to be public, if it's only being given to users who pay for it? GitHub doesn't give you a solution. There are other solutions that have been around for a long time. So all Linux distributions have that problem. When they take open source software, they often need to modify it a little bit, modify the source code here and there. And they maintain patches. There are a couple of utils for this. Kilt is something that Debian uses. RPM has something built in. It's a feature called %patch. But these are kind of outdated, because they store the changes as literal patch files. So, these files with the minus for all the lines that have been removed, and the plus for the lines that have been added. And where do you store them? You can store it in a Git repo. But okay, you store patch files in a Git repo. Look at the history of the changes to the patch file. How does it look like? It's absolutely awful, right? You can't tell what has changed, because changes to patch files are not really readable. It's like using one version control system over another. Okay, there's another option. If the software in question is a Helm chart, you can modify it with customize, but you can only modify the rendered Helm chart. So say you have a Helm chart, produces some output, some Kubernetes manifest, and you can use customize to modify some part of it. I think that's actually true for any structured file. So it could be a JSON file, and you can have some script that targets a particular part of that file. Excuse me. So you can solve it that way, but excuse me. Excuse me, just coming out of an infection just a couple of weeks ago. Still having some residual cough. So you can modify the file by targeting a part of the file in some language, like JSON path. In JSON path, you can say modify this part of a JSON object, right? Or with customize, kind of similar, right? But with YAML. So that's fine. But with Helm in particular, that only works on the rendered manifest. You can't modify the template that way. That's one limitation. So what's the GitKraft solution? I introduced the private fork feature to GitHub. So you store customizations as Git commits. And you can update the software by running a special GitHub workflow. So without further ado, let me show you how this works. So that's easiest to explain on an actual demo. So let me try doing that. Maybe let's stop sharing this guy and present the window. There you go. Yes, you can see that's it. Excellent. So this is the GitKraft organization on GitHub. Now, in here, there are different repositories. Now, they are currently private, but the idea is that GitKraft will make them public at some point. They contain Helm charts, open source Helm charts that you have used already. I want to scroll down to a particular one, a Bitnami chart. So let's say you want to modify you're going to fork this one and you want to deploy it and maybe with some customization. So let's go to it. And this is what it looks like. And I'm not going to show you everything right now. What I want to show is how easy it is to actually use it. So you get, so this repository contains the source code of the chart. And you have a new button here, the private fork button. That's not a GitHub feature. That's something that GitKraft adds. So we click here, and that gives you an option, excuse me, to create a new repo. You select the target organization. So typically, the company you work for, I'm going to call it your org 123, right? So that would be the company you work for. Now, notice here near the bottom where it says private. This is going to be a private fork, and this is a feature that GitHub doesn't provide. So let's click create repository, and this is being done. And what you will see here in a moment is a message asking you to just hold on for a few minutes. So let's click watch progress. And there's a workflow running in the background. Let me tell you a little bit more about what's happening here. So this is actually a trick. So GitHub doesn't have forks, private forks, but what it does have is the ability to create a private repo from a template. So what happened here really is a new repo has been created from a template, and that template contains a workflow, and that workflow runs immediately after the repository is created. And this workflow will actually copy the code from your source repository to this repository. And this will be a private repo. So that's the trick basically to create a private fork feature in GitHub. Now let's go to code. And I'm going to show you what happens here. So this is your private fork. You will be able to update. You have a new button called update here. Now, but let's go to commits, the history first. In here, you will see this is the history. So the interesting thing here is that at the bottom, you have all the different versions of this chart. Each new release is a different commit. At the top, you have 3 commits created automatically. The top one means that basically the one that's kind of imported to this repo is 18.2.0. Let's say we want to make a change. So let's go to code and let's make a change. Let's say it's a values YAML file. It doesn't have to be just values YAML file. It can be a different file, any file in the source code of the chart. But we're going to try with the values YAML file. So let's go here, and I'm going to click Edit. And let's assume that in your organization, you need to rebuild the images because you put maybe custom certificates into the image. And for some reason, this or another, basically a new image gets created at your company, at your organization, and has a new version. So let's say it's line 83. I'm going to add some suffix to this version. Let's say it's called -Akorzy1. Akorzy is my nickname. And I'm going to commit that. So this is my patch, right? I just wanted to note for you to notice something. This is not a patch you want to contribute upstream, right? This is often the case that you need to make a change that is kind of an adaptation to the infrastructure you're using. So doing this in the open doesn't really make sense. And again, it doesn't have to be a values YAML file. It could be any file here. So let's click blame. I'm going to show you what this looks like. Blame will tell you from which version of the chart each line comes from. So if I go to line 80, there you go. You can blame me for this one, right? This is the change. Now, the interesting thing is that you can also see the other ones. There are some interesting features here. If you hover over, for example, Nginx, let's say 13.2.0 as an example, right? And let's click that. That actually gives you, this is again a GitKraft feature. The way these charts are imported is they give this link here on the left to the original repository where developers make changes. If we click here, you will see this goes to the public repository. I think it's just slow because of the sharing. Let me refresh maybe. Let's try again. I think it's just being slow. But the thing is that you can click here and you get to the original commit from which this commit was created. The original commit is going to be in a different repo. This is the one, right? It's in a different organization. Just want to clarify, I'm not affiliated with that organization, right? They produce open source Helm charts. So I pull them, GitKraft pulls these and kind of encapsulates them, packages them up, but doesn't modify them, right? These are the original widely used open source Helm charts that I'm kind of publishing here. So let's go back. And now, next thing, what if you want to update? That's the big question. How do you combine the latest version of the chart with this customization that we made? So yeah, it's a bit slow. I think my computer is just being slow because of all the sharing, but let's click update here. And I'm going to go to run workflow. And here, now, one thing I want to mention, if you click run workflow, that will just update to the latest version. Now, I've done a little bit, I've done a trick here before the demo. I've made a little change so that when we forked, we didn't actually fork the latest version as would normally happen. We actually forked an older one because I want to simulate the scenario where a new release came up in the meantime. So the release that was actually forked here is 18.2.0, but there's a newer one. I know it's available. So let's do it's 18.2.1. If you leave this blank, that would just update to the latest version, which is also fine. But we're going to do a specific run workflow, and that's going to run in a minute. What's going to happen? The end result is that these two changes are going to be combined. So we're going to combine the patch that we made and the latest version. They are going to be combined in a special way. I'm going to show that later because it's not an ordinary merge. It's not an ordinary rebase. It's actually something special. I'm going to show that too. Let's wait for this to finish. By the way, these workflows will run in your organization. So if you have your own GitHub runners, they will be used, right? Whatever configuration you have, so that doesn't leave your organization. Yeah, let's wait for a second. Okay, it's finished. Let's go to code. And what you will find here, if we go to commits, is that, there you go. At the top, you now have a new import, 18.2.1 welded to main. But you also notice there are two commits here. So this is the original one, the update values, and then there's another one with the same name. There is a reason for that. I will explain it later. But the thing is that now we have both. We have the patch and the newest version. Now, let me show you one more thing. What if there is a conflict between the change we made and the update? So that's the next thing I want to show you. Let's go to update. And let's run workflow. And this time I'm going to update to the latest one. Because I set it up for this demo so that now that we run update, we'll go to the latest one. But the first time we did the fork, it went to an older one, just so that I can share this demo. So let's wait a second. And this will actually fail. This will fail because of a conflict. I know there is one. Let's go there. And in here, you'll notice there is a new button. Again, this is not a GitHub button, something new. Let's click here. This will take you to a PR that will allow you to resolve the conflict. You see the red message here, it means there's a conflict. So that's what I expected. Let's go to create pull request. And here you will see information, hey, there's a conflict. Let's resolve the conflict. And there you go. So what happened here? So in here, there was our patch, which was right there. It was on top of version 127.1, but the latest update has a new version of the image, 127.2. So this is why there's a conflict. So if you need to roll out your image, now you know you need to roll out the new image, add whatever patches you want, and you need to resolve this conflict. So how would you do this? You would add the suffix here. And let's remove all the other stuff we don't need. There you go. And let's go up. Mark as resolved. Commit merge. So it's an interface you're probably already familiar with, standard conflict resolution interface, but I'm kind of reusing it in a special way because this is not a merge to main. This is actually merged to a temporary branch. Let's confirm this merge. What will happen is that this is actually merging to a temporary branch called GitKraft/main from GitKraft/update. This is a technical detail, but the thing is that another action will run that will actually take this conflict resolution information and apply it to main. And this is the top job. Please disregard the second one from the top. This is just a technicality. If a job doesn't run, in some cases, GitHub displays it here with this empty circle, but yeah, it doesn't matter. I'm talking about this circle. This means it didn't run. This is the one that's running because it's yellow. So let's wait for it to finish. It's going to be done in a second. It's actually queued. There you go. It's done. So let's go to code. And let's go to Nginx. And let's go to values YAML again. And blame. And there you go. If you go to line 80, this is where we made the change. The change is here. Now, it has a slightly different name. There's a reason for that. I don't want to go into these details. It's now called combined patches, but this is the change we made in the conflict resolution. And all the changes from the latest version, which is 18.2.4, are also here. So that's it. That's how you use it. Let me now go back to the slides. I want to show you a bit more detail about how this works. And there's a trick here that I mentioned around Git merging and patching. So give me a sec, please, and I'll be ready. So there you go. So here's the question. How do you combine a private fork with upstream release? So at the bottom here is your private fork, right? Your private repo. And you made these patches, actually starting from here, 1, 2, 3, right? And here, this is the release you started from, and maybe there were 3 more releases of the chart in the meantime. So how do you combine that? So the simplest thing is to do a merge, right? You could do that. Excuse me. But there's a problem with that. In fact, this is what GitHub usually does if you do a public fork, which is fine, right? But there's a problem with that. If you do this a lot of times, so you make patches, you merge a new release, you make another patch, you make a new release, and so on, then your patches are lost in history. They're all over the history, and you can't easily say, okay, what were the changes you made on top of the version here, the last version here. So there's another option, excuse me, that I'm sure you're aware of. It's rebasing, right? So the idea is that, okay, so this is the state of the private repo, the old one. This is the new release. And what rebase does is takes this particular commit and just cherry picks it here. This one here, this one here. And you end up with this state. But there's a problem with this too. There is no connection between this and this, and that has certain side effects. If somebody else, your colleague, had checked out this repo in this state and they run git pull, they will get an error because Git will not know how to get from here to here. So that will kind of break people's workflows. And another problem is that when you're here, these commits are actually not in your history. So if you're going to just see in your history this, you're going to know you started from this GitKraft release, but where was the last one? You can't really see it. That's not going to be in your history. You could tag it, but it's not really very visible, like from here, what the previous version was. So here's the solution. And I call it a welding merge, because what happens is we do the rebase, kind of like we did before, but we add another commit here. And I call it a welding merge. It's a special merge with the custom strategy. And it tells Git, okay, make it look like a merge, but take all the state of the code from here, ignore everything that was here. So basically, it's like a replace operation. Replace the state of this branch with this branch. And it looks like a merge, so there's no connection. Somebody had checked out this repo, they can run git pull, it will cleanly go here. And you will see all of these commits in history too. So this is what GitKraft does, and I think this is the most transparent way of solving that problem. Another thing I wanted to mention, Helm dependencies. In this solution, your dependencies are also going to be stored in the GitKraft repository as source code. So you don't need to download them separately. You will see the differences between in the source code of dependencies in a given commit in the GitKraft repo. So all of the changes will be visible. Now, how do you integrate it with Argo CD and Codefresh? And that's actually very easy. You just create an application resource. You point to the repository in your organization, a particular target. You can create a tag here, and you just use standard options, and that will you can use Argo CD and Codefresh to deploy this very easily. All right, so just a summary now. Advantages of GitKraft. So you can update the chart, right, and reapply custom patches. So that's the main advantage. You also avoid delaying updates, because this is one of the problems with patching. You patch some source code, and a new release comes up that solves a security bug, but you delay the update because that would require reapplying the custom patches. This software, GitKraft, makes it easier for you to reapply it, so you don't delay updates, especially important security updates. You also get transparent history of changes to all the underlying releases, and a transparent patch list, so you know exactly what are your patches on top of which release. And you also get an audit trail, who changed what and when, which is also useful. So that's it. That's my talk. The release is coming soon. That hasn't been released yet. There are still a couple of things I need to do to really productionalize it. And one thing I would like to recommend, please start the repository. If you go to this link at the start, that really helps with the visibility of the repo. And anyone who starts it will, of course, get priority as well for support for any questions. You can also send me a free message on LinkedIn. I've configured the profile so that you don't have to be connected to me, you can just send me a free message, and you can follow me on LinkedIn. That's where I'm going to post updates. That's it from me. Do you have any questions?
Awesome stuff. Thank you very much, Aleksander. I'm sorry you're suffering with this cough. My God, I've done this before where I've had to give talks before, and your throat won't give you any. I felt like jumping in there and saying, "Listen, I'll tap dance here for a bit while you recover." Well done, well done. You powered
All
through.
right,
That's
thanks.
great to see. Yeah, yeah. So just to give some context, I actually had a couple of questions myself. I'm not seeing any questions in the comments section, which is fine. Don't forget to use the hashtag ship24 if you've got a question. But I had a couple questions myself. I for a second there, I thought, is this a Chrome extension that you've built? And I was thinking also, are you using any hidden markup to inform GitHub of actions for GitKraft to do its work?
So no, it's not a Chrome extension. It's just purely a GitHub extension. So I'm using links, special links to populate certain forms.
Okay.
I'm using reusable workflows, and I'm using features such as templates. Like I said, it's called creating a new repo from a template. That's an important feature.
Yes.
So it's
Yes.
kind of
Yes. Yes. I'm
interesting.
aware of that.
Yeah, so it's kind of interesting that when I started on this project, I thought I would have to do something like you said, maybe a Chrome extension, or my own UI, a GitHub app. Turns out I don't even have to do any of this. Just reasonably simple extensions to GitHub allow me to do this.
Yeah, I was one of the resources I commonly refer to is this one here. So I have a lot of experience using GitHub and GitHub Actions, and I don't think people really appreciate just how many events are fired by GitHub in the context of these actions or workflows firing off. So are you leveraging any of these to do the work in terms of creating a private fork of a repo?
So yes, in the sense that that the workflow responds to events on pushes in particular. But I don't have a listener to a workflow, because GitHub can also post events to a webhook.
Yes.
And it turns out I don't have to do that. I thought I would have to. It turns out I don't even have to do that. It's just a workflow implementation. Yeah.
Are you hitting? I have to also ask, because I have a lot of experience with this, so my brain was buzzing when you were talking there. Have you stumbled up against any of the API limits that GitHub has enforced?
Yes, this is always a problem, but it's not actually such a problem with this. Here's why. So
Okay.
With GitHub, there are different limits for different operations. One of the, for example, limits is for anything that sends an email.
Yes.
Opening a pull request can send an email, but pushing a branch doesn't. So this is why I used this trick, which was that I could, remember when there was the conflict and you had to click a button to create a PR? What I could have done, I could have created the PR from API, but that has the rate limit. But what doesn't have a rate limit is pushing a branch and then showing the user a button. If you click this, you're going to open a PR, because that's then actually it's not an robot that opens the PR, right? It's a human person.
Right.
So because of that, each person using this is going to have their own limit. If I was a robot doing this, then all of these creating PRs would be from that one robot. So this is one way of doing this. I think the trick to avoiding these rate limiting issues in GitHub is be aware which API call you're using and which operation you're using and what the limits are.
That is the truth. The final question I had as well, when I saw your diagram for the welding merge, I was curious, do you lose your history that's in the branch that you're welding into your private?
You don't. Okay. because really from Git, it's like a merge. Like Git doesn't really care when it shows the history, what happened in the merge commit. You could do anything you want. You can make random changes in it, in fact. But the structure is just a regular merge. Yeah.
Okay. So you mentioned that you have a few things to do before you actually ship this thing out to the world. What time frame are you looking for around GitKraft?
Now that's a tricky question. I didn't expect that one. I really am kind of afraid to promise anything, because it's
come on, gotta make a prediction.
Well, I'll definitely like to do it by the end of the year. Let's put it like this.
All right. Well, we won't hold you to that. It's great to see. Thank you so much for toughing out your cough. We all felt bad for you there, but I really appreciate you taking the time to present here. And
all right,
awesome work.
Thank you so much.